Hello everybody and welcome back to another video by Funlearn Tutorials. In this set of videos, we will be trying to understand the relationship between static games and dynamic games. To start off with the concept, we will start with a set of dynamic game and we will attempt to convert it into a static representation. Of course, static games and dynamic games are fundamentally different. We are merely trying to convert one setup into something that looks into the other apparent form of representation. We cannot, of course, convert one game into the other. So let us first start with a dynamic game. Let us first consider player 1. So the player 1 is the first player and the first person to make a decision. And suppose player 1 has two options. Player 1 can either choose capital A and capital B. So these are the two options of player 1. Now given that player 1 chooses capital A, suppose player 2 is in this node. Player 2 has then two options, which is the decision of taking small a or small b. That is if player 1 chooses capital A. If player 1 chooses capital B, then again it is player 2's decision to make his or her choice, and player 2 is again left with two options, which is small a or small b. So this is the situation that we have. Now if that happens, let us first understand what are the payoffs. So if player 1 chooses capital A and player 2 chooses small a, then suppose the payoffs are 3, 2. So these are the payoffs. That means player 1 ends up getting 3 and player 2 ends up getting 2. If player 1 chooses capital A and player 2 chooses small b, then the payoffs are 2, 4, that is player 1 gets 2, player 2 gets 4. Similarly, in this position, the payoffs are 8, 2, that is choosing capital B, player 1 gets 8, and choosing small a, player 2 gets 2. Finally, in the last position, that is if both players choose capital B and small b respectively, then they get a payoff of 3, 3. Let me just write that down properly. It's 3, 3. So suppose this is the set of dynamic, this is the representation of the dynamic game. Now if we employ the principle of backward induction, as I have explained in my previous video, I will be linking it somewhere up in the right top right corner of the video and also in the description box. As always, we will be explaining the solution through the method of backward induction, which means we will start off from the last stage and work our way up. So given player 1 chooses capital A, player 2 must choose small b because 2 is less than 4. So since 2 is less than 4, player 2 will choose small b, that is this path will be chosen. Given player 1 chooses capital B, player 2 compares between 2 and 3, which are the two numbers at the second position, and since 3 is greater than 2, player 2 ends up choosing small b. So as you can see, whether player 1 chooses capital A or capital B, player 2 always ends up choosing small b. This is a particular feature based on the payoffs that we have considered in this position. That is, in this game, the payoffs are such that player 2 ends up choosing small b in both cases. Of course, this is not necessarily true. So in this case, we see that if the game boils down to the second position, the game will essentially boil down to a payoff of 2, 4 in this case. That is, if player 1 chooses capital A. And if player 1 chooses capital B, then the game will boil down to 3, 3 because the player 2 will always be rational and will always try to maximize his or her own profit. Now if this situation be the case, then player 1 will see that if capital A is played, player 1 gets 2, whereas if capital B is played, player 1 chooses 3 or player 1 gets 3. So since 2 is less than 3, player 1 ends up choosing capital B. That means finally the game will be such that the player 1 will choose capital B and player 2 will choose small b. So this is how the game unfolds, and this is the backward induction solution of a dynamic game. So this is essentially the game tree representation. This is the game tree representation of the dynamic game. This is the dynamic component of the game. what we'll be trying to do is we'll be trying to give it a representation which will make it seem like it's a that it will make it seem like a static game. Of course, it is not true. We'll attempt to find out the drawbacks of trying to represent a dynamic game in a static form, and we'll end up with a few very beautiful results which are very pertinent in the field of game theory.